Hi, I'm Teacher Max. Last time we learned about arithmetic progression. Today we are going to learn geometric progression. Let's look at this sequence. This is the first term. This is the second term. We get the second term by multiplying 1 over 2 to the first term. And how do we get the third term? We get the third term by multiplying the second term by 1 over 2. How do we get the fourth term? Again, we multiply the third term by 1 over 2. Now this 1 over 2, they are constant. They are unchanged. And we call them common ratio. And we use R to denote common ratio. Now in arithmetic progression, we have common difference. In geometric progression, we have common ratio. We can get the common ratio by taking the ratio of the second term to the first term. 10 over 20. Or the third term to the second term. Or the fourth term to the third term. We'll get 1 over 2. Now let's look back at the progression. 20 is the first term. 10 the second term. 5 the third term. We get 10 by multiplying 20 by 1 over 2. 20 is the first term. A. 1 over 2, the common ratio is R. We get the third term by multiplying the second term. 10 by 1 over 2. But then, this 10 is also 20 times 1 over 2. This one is 10 times this 1 over 2. And we get 20 times 1 over 2 squared. We get the fourth term by multiplying the third term. 5 by 1 over 2. But 5, this 5 is also this one. 20 times 1 over 2 squared. This one is 5 times this 1 over 2. And we get 20 times 1 over 2 cubed. Now note that this number here is always 1 less than this number here. This one is 2. Here is 3. This one is 1. Here is 2. So, if we want to find the 10th term, T10, what is T10? T10 is going to be 20 times 1 over 2 to the power of 9. This number is 1 less than 10. And if we want to find Tn, Tn is going to be, now 20 is the first term, A. And 1 over 2 is the common difference. 1 over 2 common difference. And to the power of, this number should be 1 less than the number here. So here is going to be n minus 1. So we get the equation to find the nth term of a geometric progression. That is Tn equal first term times common ratio to the power of n minus 1. Let's look at one more geometric progression. Here, the first term is 3, common ratio is -2. List the first 5 terms. Right, the first term is 3. The second term would be the first term 3 times -2, and we get -6. The third term is going to be -6 times -2, which is 12. The fourth term is going to be 12 times -2, which is -24. The fifth term is going to be -24 times -2, 48. Note that when the common ratio is negative, the positive sign and negative sign alternate each other in the progression. Determine if each of the following sequence is a geometric progression. To determine whether this is a geometric progression, we see whether we get a common ratio in the progression. This is T1, T2, T3. Common ratio is T2 over T1 or T3 over T2. Right, T2 over T1 is 10,920 over 10,400. We get 1.05. 11,466 over 10,920. We get 1.05. Both are the same. We have a common ratio. So this is a geometric progression. We do the same for the second one. T2 over T1 is -2m plus 8 over m minus 4. We factor out -2. Simplify, and we get -2. T3 over T2 is 4m minus 16 over -2m plus 8. We factor out 4 up there, and then factor out -2 down there. Simplify, and we get -2 also. Since both are the same, we have a common ratio. So this is also a geometric progression. Find the 8th term of this geometric progression. Here, the first term is 36. So A is 36. Next, we find the common ratio. We take the ratio of the second term to the first term. 12 over 36 is 1 over 3. So R is 1 over 3. Now to find the 8th term, we make use of this equation. What we want to find is T8, the 8th term. A is 36. We plug in this number. R is 1 over 3. We plug in this number. N is 8. We want to find the 8th term. And we get 4 over 243.